Welcome back. So in today's class, let us discuss in detail regarding the worksheet number 4 numericals, and then let us move to the worksheet number 4a. So let us begin with the numerical part. First question, the change in kinetic energy per unit space or per unit distance is equal to. Children, as we know that the work done W is equals to change in kinetic energy. From work energy theorem, we know that the work done is stored in the form of change in kinetic energy. And the formula for work done is nothing but the product of force and displacement, or force and distance. Because work is a scalar quantity, let me read it as distance. Okay, so force and the distance through which it has displaced into equals to change in kinetic energy, or F can be written as change in kinetic energy upon the distance through which the body is being displaced. Hence, we can conclude that the change in kinetic energy delta Ke per unit space, per unit distance is nothing but force. The change in kinetic energy per unit distance is nothing but force. Hence, option 3 must be true. So, answer is force. So, moving ahead with the next question, second one. When the momentum of a body is doubled, the kinetic energy is. So, what is the relation between kinetic energy and momentum, children? As we know that kinetic energy equals to P square by 2m. What is the relation? Kinetic energy equals to P square by 2m. In short, instead of Ke, let me write it as K. So, K equals to P square by 2m. Given that when the momentum of a body is doubled, so what happens to the momentum? Momentum changes, it is doubled. Of what? Of a body. So, body, only the same body, only momentum is doubled, keeping the body as it is. The kinetic energy of the body is very clearly, we know the 2 is constant and m is also constant because same body. So, mass remains same. So, we can conclude that K proportional to P square. If K is proportional to P square, then we have K1 by K2 equals to P1 square by P2 square. Or taking the reverse values, K2 by K1 is equals to P2 square by P1 square. So, this let us consider. So, what are the values, children? K2 by K1 equals to P2 square by P1 square. Substituting all the values, let us find out what happens. So, K2 you are asked to find out because the kinetic energy is initial kinetic energy, some K, I'll write it. So, initial kinetic energy, some value, some K, I'll keep it equals to P2. What is P2? Momentum of the body is doubled. So, initially, let us suppose that K1 equals to K, P1 equals to P, and P2 will be how much? Momentum of the body is doubled means it will become 2P. These are the given relations. So, instead of K1, I replace it with K. And here P2, instead of P2, what should I replace? 2P. So, 2P whole square upon P1. What is P1? It's P itself. So, P whole square. P2 square, 2P square, and P1 square is P square. So, K2 upon K is found to be 2 square is 4P square upon P square. So, simplifying further, P square and P square gets cancelled, or the value of K2 by K equals to 4, or K2 is equals to 4 times of that K. So, what did you found, children? You observed that the new kinetic energy becomes 4 times of the old kinetic energy whenever the momentum is doubled. So, this was already explained in the concept, children. Whenever kinetic energy becomes x times, whenever momentum becomes x times, kinetic energy becomes x square times. So, whenever this momentum becomes twice, kinetic energy must become 4 times. Hence, the correct answer is option 3 becomes 4 times. For the same kinetic energy is constant. The momentum shall be maximum for which of the following particles? So this is again a different concept, children. So you are asked given 4 particles. One is electron, proton, deuterium and alpha particles. So you know the value of electron, which is very lighter. Okay. So in the atom, if you consider, electron is a very lighter particle. Okay. So but if you compare the mass of electron with the mass of proton, always remember that, children, mass of proton, I'll simply write proton as P, is equals to 1836 times of mass of electron. So how far it is? The mass of proton is equals to 1836 times of mass of electron. So proton's mass is comparatively large when compared to the mass of electron. So this we can conclude that mass of proton is greater than mass of electron. This is one point. So you are asked to find out for the same kinetic energy, momentum shall be maximum for. First of all, momentum. What is the formula for momentum? Momentum equals to mass into velocity. Okay. And kinetic energy is same. So relation between kinetic energy and momentum is P is equals to root over 2mk. P is equals to root over 2mk. So here somehow we know that 2 is constant and given condition kinetic energy is also constant. So P equals to root m. P is equals to root m. So larger the mass, larger will be momentum. Lesser the mass, lesser will be momentum. So when comparing mass of proton and mass of electron, whose mass is more? Proton's mass is more. So proton will be having more momentum. So larger the mass, larger will be momentum. But you are given 4 particles. We have still compared electron and proton. So when compared to electron and proton, proton has heavier mass, hence larger momentum. So let us ignore electron. Now let us compare proton with deuterium. So what is deuterium? Deuterium is nothing but a mass of proton along with the mass of neutron together gives your deuterium. If mass of proton is greater than mass of electron, no doubt the sum of mass of proton will be greater than the mass of electron as well as the proton. So very clearly we can conclude that. So mass of proton plus mass of neutron is greater than mass of proton, individual proton. But what is mass of proton plus mass of neutron, which is nothing but mass of deuterium. So mass of deuterium is greater than mass of proton. With this we can conclude that this mass is greater than mass of proton. Now coming to and compared to electron, proton and deuterium is having the highest mass, hence highest momentum. Now one more is left over, alpha particle. Children, what is alpha particle? Alpha particle is nothing but helium particle. Helium whose atomic mass is 2, atomic number is 2 and mass number is 4. So clearly this indicates that the mass of alpha particle is 4 times of the mass of proton. Mass of alpha particle is 4 times of the mass of proton. So here we can conclude that this is only 2 times. Mass of deuterium is only 2 times of the mass of proton. But mass of alpha particle is 4 times of the mass of proton. Why? Because children, once you remember that mass of neutron is almost equivalent to the mass of proton, almost similar. So the reason why I wrote it as 2. So from all the discussions we have made till far, I can conclude that mass of alpha particle, which is equals to 4 times of mass of proton, is greater than mass of deuterium. Deuterium I will simply writing it, which is only 2 times of the mass of proton. And this deuterium mass is of course greater than mass of proton, and which is mass of proton is greater than the mass of electron. This is our conclusion. So mass of alpha particle is greater than mass of deuterium, and mass of deuterium is greater than the mass of proton, and mass of proton is greater than mass of electron. This implies that momentum of alpha particle is greater than momentum of deuterium is greater than momentum of proton, which is greater than momentum of electron. So among the four, which particle is having larger momentum, children? Obviously alpha particles. Hence our answer is alpha particle. Okay. Since mass is directly proportional, root over mass is directly proportional to momentum. So we can even say that instead of P alpha, I can say P square, P square, P square. This gives you more clarity.